Okay, Assalamualaikum warahmatullahi wabarakatuh. So now let's move to the chapter 3. So let's recall back what have you learned in chapter 1. You learned about the current and what is voltage and what is the power, right? And then in chapter 2, you learn about series and parallel, what is a KCL, KVL, and what is Ohm's law. And then relate to here is the current division and also voltage division. So now let's move to the more complex analysis that is called method of analysis. So in order for you to understand this chapter, you need to really understand what is KVL is all about. KVL is the summation of the voltage across the loop or junction. So if it is a voltage, it need to be across the loop is equal to 0. So this KVL will lead to the first terms in this chapter 3, that is what we call mesh analysis. Okay, so if you read this statement here, this is from the textbook. It say here, the word here is no great work is ever done in a hurry. So you will have a long and complex analysis for this chapter that is having like more than two or three equations together. So to do anything great, it requires time, patience, and perseverance. The things are done by degrees, little by little. So in order for you to really understand this chapter, first please make sure you really understand what is KCL and KVL is all about. KCL is at the nodes and KVL is at the loop. So once you really understand what is KVL and KCL, so the step on this circuit for this chapter, you need to do step by step in patience. So once you already master these steps, so inshallah you can really understand this chapter. Okay, so let's recall back. What is node? So node is there are two branch or three branch. So this is what we call, how many branch here? 1, 2, 3, right? So this is what we call a node. Okay, so what is the difference between essential node and only the normal node? Essential nodes means point of 3 or more elements are joined. So for node A, so let's say this is node A and this is node B. Node A, it is only joined between two branch, right? So we didn't call this one essential node. So which one is essential nodes? Node B and node C is the essential node. Why they are essential nodes? Because they are connected between 3 or more. So this is 1, 2, 3, right? Then here is also 1, 2, 3. So this is concept is important for you to identify which one is essential nodes. So in this case, the essential node is B, C. The nodes itself is A, B, and C. Okay. Branch. What is branch? Is the element that connect two nodes. So how many branch we have here? 1, 2, 3, 4, 5, 6 branch. How about the loop? So let's say I complete these circuits. 1, 2, and 3 loops. Okay. And the mesh is the loop that does not enclose any other loop. So what is this means? You need to go back to what we call planar circuits. Okay, now let's test your understanding here. How many branch first? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 branch. Okay. How many nodes? So here we have 1, 2. This is the same node, right? All here are the same nodes. So consider here 1, 2, 3, 4, 5, and the below one is 6. 6 nodes. Now, what is essential nodes? Is the nodes that is having 3 or more branch connected together. So let's say, which one? 1, is it essential? No. How about this one? Yes, because it connect by 1, 2, 3, 4, 5, right? Okay, this is number 1. How about Note number 5, 1, 2, 3, yes. So this is essential note number 2, and this is essential note number 3, and this one is essential note number 4. So we have 4 essential notes here. So you can ignore this one. Okay, so what is mesh? Mesh is the loop. So we have 1, 2, 3, 4, 5, 6. 6 loop means 6 mesh. Okay. So in this chapter, what you're going to learn is about nodal and mesh. So when we're thinking about the mesh, it's actually the loop. When we're thinking about nodal, it's a node. So once you know the node, there is KCL. Once you know the loop, there is KVL. So let's start with what we call mesh analysis. So for this mesh analysis, you have two. One is without current source. Current source is denoted by the arrow, right? And the one with current source is case number 2. So what is actually mesh? Mesh is a loop. When we're talking about mesh, you always remember about KVL. The loop that does not contain any other loops inside. So what is a loop? Loop is a closed path. Closed path. Mesh only can be applied to what we call planar circuit. Planar means what? Planar is the circuit that can be drawn in a plane with no branch crossing each other. Okay, so let's see how is the circuit of planar looks like. Okay, before that, when you're talking about mesh, you need to apply KVL. And you only work with what we call imaginary currents. So you're making that, let's say this is loop number 1, you imagine the whole loop is I1. Loop number 2, the whole loop is I2. And it can only be applied to what we call planar circuit. So what is planar circuits? This mean like only there is no path that is crossing each other. So if you redraw this one back, so it become 1 here, 4 and 3 remain the same, right? But how about 5? 5 you can just take out the wire, so it become like this 5. And 6 also, you take out the wire, it become 6. So it not crossing each other actually. So this is what we call planar circuit. So can you apply mesh here? Yes. How about these circuits? So this is a non-planar circuits where this 13 ohm and 13 ohm is crossing to one dimension to another dimension. So this is what we call non-planar. You cannot apply mesh here. Okay. So since you cannot apply mesh here, you need to use what we call nodal analysis. Okay. Now how we set our mind here? Mesh, always think about a loop. How many loop? Depend on how many closed paths in the circuits. After the loop, you do your KVL, and in each loop, you are going to denote by what we call imaginary current. So let's say this is 3 loop. You have 3 imaginary current, I1, I2, and I3. Same with here and here. So there are 3 current here. And then you apply KVL. Always make practice to make it clockwise. Clockwise. Yeah, always make practice to make it clockwise. Okay. So let's see what is the type of mesh. One is without current source, with current source. In one mesh, what does it mean? Your current source is the most left or the most right, and then you have here a resistor and another circuit here. So this is means at one mesh. There is another type where the current source is between 2 loops. So this is what we call with current source between 2 mesh. How you going to solve it? Okay, and the first one is without the current source. Okay, what is the steps? Okay, first when you're talking about mesh, always KVL. Assign the imaginary current. Use your KVL. And then solve it using simultaneous equation. Either you're going to do by substitution or elimination, or what we call Cramer's rule. So this one, there is explanation in the textbook. So if you have the textbook, you can use this one. Or the most shortcut ways, just use your calculator to solve for the simultaneous equation. Okay. Okay, so this is a summary. Label the imaginary current. What is this one? I1, I2. Apply KVL, solve the linear equation, and it only works with planar circuits. Okay, class. So, let's start to solve first example. Okay, now look at these circuits. You have how many loops? So, you have 2 loops, means 2 mesh. So, you just denote, assign the mesh current. So, you put the loop here. This is what we call imaginary current, the mesh current. So, we have 2 currents, I1 and I2. So, how are you going to start? Always start from here. So, let's say in your loop number 1. So the equation starts with minus 36 plus 2. You need to use KVL, right? So this is what we call KVL. Voltage, voltage, voltage. 2I1 plus, now look at this one, 12. So now the current across this 12 going down is I1. Looking from this imaginary current. But going up here is what we call I2 because of the imaginary current at the right side. So if I redraw back, so you have 12 ohm here. Current down is I1. Current going up is I2. So you need to find the net current across 12 ohm. So the net current need to be, what is the current loop now? The current loop is number 1, right? So it need to be I1 minus I2. Okay? Because you are currently in loop 1. Okay? And then the last one is 4I1 equal to 0. Okay? So, if I simplify here, minus 6, 2I1 plus 12, I1 minus 12, I2 plus 4I1 is equal to 0. You simplify further, it becomes 18I1 minus 12I2 minus 36 equal to 0. So, this will be equation number 1. Okay? Okay, now move further to loop number 2. Again, you use KVL. So, starting from here, again, you have 12 there. But now, the 12 here at the loop number 2, the current pointing up is I2, right? Current pointing down is I1. Since you are currently doing this loop here, so it need to be I2 minus I1. Because you are currently in loop number 2. So plus 9 here, I2 plus 24. And then the last one is plus 3I2 is equal to 0. So if you simplify further, it becomes 12I1 plus 9I2 plus 24 plus 3I2 is equal to 0. And then you can get minus 12I1 plus 24I2 plus 24 is equal to 0. Okay, so this will be equation number 2. So just you can use 3 types to solve this simultaneous. One is what we call substitution, or you want to solve for elimination, or you just use calculator to solve it, or you can also use Cramer's rule. So it's up to you which is you familiar with the steps. So if I use the calculator, then you can get I1 is equal to 2 ampere, I2 is equal 0 ampere. Okay, so I already teach you how to solve this one using calculator. So you can just cut the shortcut way, use the calculator, or you can just use the Cramer's rule, where you can learn this from the textbook. Okay, so that's all for this video today. So the most important part here is this one, 12 I1 minus I2. But if you are in the loop number 2, 12 I2 minus I1. Okay, so that's all for this video. Assalamualaikum.